All right, so we're in section 7.2. We're looking at area between two curves and how we can calculate that. So we start off with this example of these functions here. What we have the function f of x equals secant squared x. And then the bottom function is g of x equals sine x. And we're actually looking from 0 to pi over 4. And our goal is to find the shaded region. So this might actually look familiar to an extra credit question from the last exam that we took, where you had to basically just write how you would find the area of this region using integrals. Okay, so if we think about it, the entire thing, so this shaded area plus this area right here, would be given by the integral from 0 to pi over 4 of secant squared x. Right? But if we subtract this area here of sine x from 0 to pi over 4, which would be the integral from 0 to pi over 4 of sine x dx, if we subtract that area, then we're going to end up with just the shaded region here. And so that's what we're doing. And we're actually going to look at the two different ways that we can do that and how we can write that out. So we can actually write that just as one integral, or equivalently, you could essentially distribute the integral to both f of x and g of x. So when we integrate this function, f of x is secant squared. The antiderivative of secant squared is tangent. G of x is sine. And since it's negative, it's minus sine x. That's just a positive cosine when you anti-differentiate. Then we're evaluating from pi over 4 to 0. And tangent of pi over 4 is 1. Cosine of pi over 4 is square root of 2 divided by 2. Minus tangent of 0 is 0 plus cosine of 0 is 1, so it's minus 1. We're just left with root 2 over 2. If we look at just essentially distributing this integral and dx to each function, you end up getting the exact same thing. Tangent of x evaluated at pi over 4 to 0 minus negative cosine, which of course is plus. You get the exact same answer. So now looking at another example, and this one might actually be found in your homework assignment. We can think about finding this shaded area by breaking it down using subregions, especially if there's more than one function involved. In this case, we have 3 functions that are involved here, and so we have the function y equals x, then the function y equals 1 takes over, and then the function y equals x squared divided by 4 is actually used in both. It is that lower function right here. So take a second and sketch this out pretty well. So how we actually are going to break this apart is noticing that at this point here, when x is 1, is when this function, the difference between the two functions, actually changes. And now the function y equals 1 is where we are beginning to, basically that's your upper bound to the shaded area there. So right here, and sometimes we need to use our calculator to find these points of intersection. In this case, it's given to us that at y equals 1 is where we are going to have to switch. So we could think about this first part as region A, and then if we think about just naming this region B, if we find the area of A and add it to the area of B, then we've got the area of the entire shaded region. Okay? And so you're going to integrate for A, you're going to integrate from 0 to 1 of x minus x squared divided by 4. This is x. This is x squared minus 4. That's what you're going to subtract. Region B is the integral from 1 to 2 of 1 minus x squared minus 4. Sorry, divided by 4. Okay? So you can actually see those there. And so you can see on this particular problem, I didn't necessarily show my work. You'll need to do that. But just to try to keep this video short, this is something we're all capable of integrating. Notice I did name this region A, I named this region B, so I can, if this problem is longer, I can just write A and B, and that actually represents what this integral equals. So just in future problems, we'll do that quite a bit. We are going to spend one more day with this section, and the homework assignment, it's not super large, but it's not small either. So I want to give you guys some time to work on that. It's going to be right here. It's going to be due not Monday, but due Thursday. So we have class again on Wednesday. We will finish this section 7.2, and then this assignment will be due Thursday.